when you see this question, you see all these little trig functions and you want your variable in the numerator. That really is your goal, because if you don't have the variable in the numerator, then you're going to have to do the quotient rule. So your option is to somehow get this variable in the numerator or go through the quotient rule. So oftentimes what we want to try to do is we want to simplify as much as we can. And there is simplification that can make your life significantly easier on this question. So if you have 1 over sine x, that is equal to our cosecant x. And if we have 1 over cosine x, that's equal to secant x. And remember, there's kind of like this little mismatch of c's and s's when you deal with cosecant and secant. So we want the variable in the numerator so we don't have to go through the quotient rule. So one way that we could do that is we could take this 3 over sine x and say that 1 over sine is cosecant x, so this would become 3 cosecant x. Okay, and the same thing goes with the 7 over cosine. I could put that cosine and say, okay, it's 1 over cosine, so that's really going to be a secant x. And then plus sine, the variable's already in the numerator, so I'm very happy with that. So this would be y. This would be our rewritten function. We haven't taken a derivative yet. But now that the derivative, or now that the variable, excuse me, is in the numerator, what I could use is I could use my derivative rules for cosecant and secant. So remember, for those functions, you need 1 tangent and 2 secants, or similarly 1 cotangent and 2 cosecants. And we remember that if we differentiate dc negative, if we differentiate a c function, we get a negative. So for this first term, when I take y prime, I have a c function, so that's going to give us a negative when we differentiate. I have 1 cosecant, so I need another cosecant and a cotangent. Okay? Minus the 7. Now for secant, I will get a positive derivative, so that minus sign is going to stay as a minus sign. And then I have 1 secant, so I need another secant, and then I need a tangent. Okay? And then for sine, we are going to have cosine x when we take the derivative. And the great thing about this is you're done after that. You did not have to go through any quotient rule, and that was made possible by using your trig functions and their identities.